Hello students, in this part we will be dealing with more general solutions, that is sin theta is equal to sin alpha, cos theta is equal to cos alpha, equalities involving squares of the trigonometric ratio, solving two simultaneous trigonometric equations at once, then we will be having principal solution and the way to find its principal solution. So let's start. Now the next example we have, or some formula that we are going to discuss here, is sin square theta is equal to sin square alpha, giving me a solution of the form theta is equal to n pi plus minus alpha. Now why is it so? We will have a discussion on that. We earlier said that if angle is of the form of multiple of pi plus minus angle, the unknown angle, then we can have the change, no change in the trigonometric ratio, and that is the situation here, that is sin square theta is again coming out to be sin square alpha. So sin is remaining sin, hence the solution set would be of the form multiple of pi plus minus alpha. Now why plus minus alpha? Because if I break sin square theta is equal to sin square alpha, I would get sin theta is equal to plus minus sin alpha. Now sin theta is equal to sin alpha, as we all know, that lies, the solution would lie in first and second quadrant, because sin is positive in first and second quadrant, whereas for sin theta is equal to minus sin alpha, the solution set can lie in third or fourth quadrant, because sin is negative in third and fourth quadrant. So simultaneously I will have two solutions. The positive ones would be 2 pi plus alpha and 2n plus 1 pi minus alpha, that is odd minus alpha, and even plus alpha, even multiples of pi plus alpha and odd values of pi minus alpha. For the negative ones, I will have odd multiples of pi plus alpha and odd even multiples of pi minus alpha. So all these four solutions need to be covered, as they are satisfying the equation sin square theta is equal to sin square alpha. So this is the only way I can cover all the four solutions, and same logic goes for cos square theta is equal to cos square alpha and tan square theta is equal to tan square alpha. Next type of questions that we have are sin theta is equal to sin alpha and cos theta is equal to cos alpha, giving me a solution of the form theta is equal to 2n pi plus alpha. Now why is it so? Because if I look at individually the first equation, I will have the solution set in first or second quadrant, whereas if I look for the solution set in the second equation, that is cos theta is equal to cos alpha, it will have the solution set either in the fourth or the first quadrant, as cos is positive in fourth and first and sin is positive in first and second. I need to solve them simultaneously. These equations need to be solved simultaneously. So I need to have a region where both the regions would overlap each other and the common solution would lie in that region itself. So if I compare the two regions, the first quadrant would give me the solution, and this is what first quadrant is defined as 2n pi, that is along the 0 degree, it's an even multiple of pi. So for any value of pi, integral value of n, 2n pi would lie along the 0 degree, plus alpha, that would surely be lying in the first quadrant. Same logic can be applied for sin theta is equal to sin alpha and tan theta is equal to tan alpha, as this would be positive in first and second, and tan theta would be positive in first and third quadrant. So again, this is the common region for tan and cos, first and third for tan, and first and fourth for cos. Again, first quadrant would be common, that's why we have the same form of solution. Now what's the principal solution? Principal solution is the basic solution that shall lie in the first quadrant itself, in the first circle itself. As in, if I am having a value, so I already know that the values of the solution for the trigonometric equation would be periodic in nature. So I need to have the first basic value that would lie in the first circle. And how can I do that? You need to first check for the quadrants where the angle may lie superficially. That is, if I have sine theta is equal to sine alpha, then superficially I know that the probable quadrants for the solution would be first or second. Then if the angle is in the first or second quadrant, then you can have anti-clockwise direction. That is, for first and second quadrant, anti-clockwise direction must be implemented, and if the angle is in the third or fourth quadrant, then clockwise direction. Why is it so? If it is in the first or second quadrant, then I must choose this direction, and for the third as well as for the fourth, I shall have this direction. We'll come to it later why we do so. Then principal value is never greater than pi. That itself is the reason why we do so. Because if suppose my value is lying in the third quadrant, if I choose to go like this, the value would be greater than pi then. So it should numerically never be greater than pi. Never greater than pi. That's why when I have first and second quadrant, I choose anti-clockwise, and for the third and fourth, I choose clockwise direction. And principal value always lies in the first circle. That is, if the first circle is defined by 0, 2 pi, that is the first rotation. Now, algorithm for finding the principal argument. Principal argument is basically the principal solution or the value of the angle that shall be less than 180 degrees or pi, and that shall lie in the first rotation itself, in the first circle itself. So algorithm is, first draw the trigonometric circle and mark the quadrants in which the angle may lie. So that will be according to the equation that we have or the question that we will be dealing with. So I have drawn the circle already. Next thing, select anti-clockwise direction for first and second quadrant. That we already know that for first and second quadrant it will be anti-clockwise, and for the third and fourth it will be clockwise. Then find the angle in the first rotation. That is how we define the principal argument, that it has to be lying between 0 and 2 pi. Then select the numerically least value among the two values. What does that mean? That actually means if I have the value of, let's say, cos theta is equal to cos alpha, I would have theta is equal to plus minus alpha. That is, it will be true for first and fourth quadrant. These are the two probable quadrants. So it will be true for both the quadrants. Now among the two values, that is theta is equal to alpha and minus alpha, I shall choose alpha as the principal argument and reject minus alpha. This is just a convention, so I would choose theta is equal to alpha in that case. So from this we have the angle must lie in first rotation, and of this numerically two values, I have to select the least value, least angle among the two values. Or suppose if I have for sine theta, let's say the two values would be lying, first one would be this and second one would be 180 minus pi. So of these two values, suppose this is 30 degrees, so this would be 150 degrees. Now among the 150 degree and 30 degree, I would select 30 degree as my principal argument and reject 150 degrees. Now have some fun. Tan inverse of 1 by 2 or plus tan inverse of 1 by 3 is pi by 4. If I have tan inverse of 1 by 2 plus tan inverse of 1 by 3, let's solve it. That's the LHS. I will have tan inverse of 1 by 2 plus 1 by 3 whole over 1 minus 1 by 2 1 by 3. Please solve it and you will get pi by 4. So students, in this part we learned how to find the general solution to equations of the form cos theta is equal to cos alpha when we have equalities of the squares of trigonometric ratios, and for the equations involving simultaneous solving of the two trigonometric equations. We discussed the principal solution and the way to find its algorithm. In the next part, we will be discussing some examples based on the concept we have learned till now. So stay tuned.